Hi, good morning, good evening, students. This is CS brand of chemistry. So today I am going to discuss about some previous 𝗤𝗓 advanced paper questions related to topics also. See, the topic name is what are the solutions. Okay, and in this colligative properties also we have to take colligative properties. Okay, na? So generally in the solution chapter here, Raoult's law is very important. On the base of 𝗤𝗓 previous advanced questions only I am taking the topics. So one is what Raoult's law. Okay, na? Right? Another one is what are the depression freezing point. Depression in freezing point. Okay. Elevation in boiling point. And Van 't Hoff factor. Related to these problems only I am going to discuss here. So you know what is the Raoult's law. First of all, I am briefly just discussing about these things here. Then after we go to the problems. See, what is the Raoult's law? Raoult's law means what here? According to Raoult's law, see, according to Raoult's law, PA is equal to what? P naught A into what? XA. And PB is equal to what? P naught B into what? XB. Okay, what is the PA here? What is the PA and PB? PA and PB are called as what? Referred as what? Partial pressures. That means the partial pressure of the solution, which is equal to the vapor pressure of pure solvent, and that is multiplied by its mole fraction. The statement of Raoult's law will be like this. Whenever you are taking a solution, the partial pressure of a solution, that which is equal to the vapor pressure of pure solvent, and which is multiplied by its mole fraction, where P naught A is called as what are the P naught A is called as what are the vapor pressure of pure solvent. PA is called as what? Partial pressure. P naught A is called as what? Vapor pressure. And X is the mole fraction. This is the Raoult's law actually. Okay. What is the total vapor pressure? PT is equal to what? PA plus what? PB. Sum of the two partial pressures. This is one type of Raoult's law, form 1. We can say this is form 1. The another law also there. What is that law means? P naught minus PS by P naught is equal to XB. Means the relative lowering of vapor pressure of a dilute solution is equal to the mole fraction of the solute. It is purely applicable to what? Dilute solutions. That means the relative lowering of vapor pressure of a dilute solution of a non-volatile solute is equal to the mole fraction of the solute. The solution must be dilute and a non-volatile solute also must be there. This is Raoult's law form 2. This is Raoult's law form 2. This is Raoult's law form 1. This one. This is applicable to purely for dilute solutions, and this is applicable to only for ideal solutions. Anyhow, these are the two types of what are the equations for the Raoult's law. Okay na? Now coming to the point, just listen, you know everything, but the thing is related concepts, which type of problems are coming and concepts are asking in the JEE Advanced means this type of things asking. And you know the what is the delta TB and delta TF. Delta TB means what? Elevation and boiling point. Delta TF means what? Depression freezing point. See, whenever you are taking delta TB is equal to KB into what? M. What is the relationship between the delta TB and molality means? This you just remember. In the same way, delta TF is equal to KF into what? M. Okay? Depression freezing point, this is called as what? Molality. And here KB is called as what? Elevation boiling point constant. Otherwise we can say what is the ebullioscopic constant. It is depression freezing point constant or cryoscopic constant. So these are the equations related to what is the molality and what elevation boiling point and what are the depression freezing point and for molality. Like this I am taking. This thing also you just remember. Okay na? Now for any colligative property, whether whatever it may be, you take what is the delta TB is equal to what? KB into what? M, and delta TF is equal to what? KF into M, and just now I have explained here P0 minus PS by P0 is equal to XB. For any type of colligative property, if suppose an electrolyte is present in a given problem, you remember, if suppose in a given problem electrolyte is present, then definitely we can take the what is the Van 't Hoff factor, that is I. You remember that point. This is called as Van 't Hoff factor I. So according to Van 't Hoff factor, I is equal to 1 plus n minus 1 alpha for dissociation process. In case of what is the solution, if suppose any electrolyte is what is the undergoing dissociation process, then we are going to consider the equation I is equal to what? 1 plus n minus 1 into alpha, where n is equal to what? Number of ions. Alpha is the what is the degree of dissociation. You just remember these things here. Okay na? So on the basis of this, how to ask the problems in the previous years means, one problem I am writing here, you just note down. The problem is like this. The problem is like this. On dissolving, I am writing the problem also. You try to do. On dissolving 0.5 grams of non-volatile solute. Solute means ionic solute. This is ionic solute. Ionic solute to 39 grams of benzene. Okay. Its vapor pressure decreases. Its vapor pressure decreases from 650. From what is the 650 mm of mercury to 640 mm mercury. The depression of freezing point of benzene, the depression of freezing point of benzene, that is in Kelvin, upon addition of the solute is the depression of freezing point of benzene upon addition of the solute is asking like that. And data is given. What is the data? The data is molar mass and molar freezing point depression constant of benzene. Molar mass is given. Molar mass and molar freezing point depression constant of benzene. Molar mass of benzene, right? C6H6. How much means? 78 grams per mole. Okay. And molar freezing point depression constant means Kf is given. Kf is how much? 5.12 kelvins, kilograms per mole. This is the question asking. You just note down. Then I will explain. On dissolving 0.5 grams of non-volatile ionic solute, okay, to 39 grams of benzene, its vapor pressure decreases from 650 to 640 mm of mercury. The depression freezing point of benzene upon addition of the solute is asking like that. Asking what is the depression freezing point is asking. That means delta TF is asking. Delta TF he is asking how to calculate. Okay, note down all of you. So finally, the question asking delta TF. How to do? How to start? So here I am using the word Raoult's law. Just now we have discussed about the Raoult's law. On the basis of the Raoult's law, we can get the equation. Finally, we take the relationship also. Okay. So okay, now I am erasing this one. Now I am going to start. You just see here how to do this problem. How to do this problem means you take P0 minus PS by P0 is equal to XB. P0, say P0 minus PS by P0 is equal to what? XB. You just assume A means solvent, B means solute. Assume like that. B means solute, mole fraction of the solute. See, I am taking now P0 minus PS by P0 is equal to what? NB by what? Actually, NA plus NB. You know now mole fraction. But here NB is what? Negligible. In case of what are the dilute solutions, NB is what are the, I think everybody knows, less than what? Na. So that's why we are taking what? Only P0 minus PS by P0 is equal to what? NB by what? Na. Got it? So NB by Na means what? NB means WB by what? MB. This is what? WA by MA. That means MA goes to what? Numerator. So that means P0 minus PS by P0 is equal to, now you see here what is the weight of the solute. Otherwise, you take this one again, one more time. WB by what? MB into MA by what? WA. P0 value is given, na? What is the P0 value? Vapor pressure of pure solvent. How much here? 650. Minus this is what? 640. This is again what? 650 is equal to, what is the WB? And you see here, non-volatile solute, no problem. No need to take the, what is the, is a benzene actually, so no need to take the I factor. If suppose if you are taking also no problem, but I factor is 1 only. Benzene it is, whenever you are taking, what is the benzene I factor? I is equal to what? 1 only, na? So no need to take. Right? If you are interested, you take, no problem. But I value is 1 only. Benzene it is not undergoing dissociation. No? It is not electrolyte. So that's why I value is 1. So anyhow, if suppose I am taking WB, what is the WB value? See the problem, all of you, 0.5. This is MB. We don't know now. We don't know about the molecular weight of that particular solute, non-volatile solute. What is the another one? Benzene. Na? Benzene molecular weight is how much here? C6H6 78. Is it? Divided by, what is the weight here? 39 grams. 39 grams. So this is the way of procedure to calculate the molecular weight of this what? Solute. So you have to simplify. Whenever you are simplifying molecular weight, I am writing here. So MB is equal to how much means, if you are simplify yourself just. Okay na? 64 grams you are going to get. $64 grams. Still we didn't get the what is the result. So this is a one step only, like this. Come on, note down. Got it now, all of you? Asking delta TF. Still we are not getting. The first initial we have to take the step like this. What is that? P0 minus PS by P0 is equal to XB. And I am writing like this. Actually NB by NA plus NB. Why I am negligible here? In case of dilute solutions, you remember always NB will be always less than. Solute molecules are always less than when compared to solvent. So in the denominator part we are negligible, not in the numerator part. That you remember. So just I am writing like that. Everybody knows NB by NA, number of moles. Number of moles means what? Weight by molecular weight, na? And I want to multiply with the Van 't Hoff factor. If it is electrolyte or non-electrolyte, whatever it may be. It is a non-electrolyte, na? Benzene, which is not undergoing dissociation process, that's why I is equal to 1. Any electrolyte is there, in that case we can do. Suppose for example, sodium chloride is there, NaCl. In this case, I factor is what? Sodium plus Cl minus. Breaking is 2. 2 ions are formed, na? So I value is equal to what? Number of ions, I is equal to what? N dash. So I is equal to what? 2, like that. So but in case of benzene, what? I is equal to what? 1 only. So anyhow, I is equal to 1. The remaining things as it is, in the given data is given everything. So MB value calculating, 64 grams. But I want what here? Delta TF, na? Shall I erase this one? Okay, now? Now next step. Finally we are going to get the result like this. Delta TF is equal to what? Everybody knows. Delta TF is equal to what? Delta TF is equal to, is asking this one only, na? KF into M. KF into what? M. So delta TF is equal to what? KF. What is the M? M means molality, na? Weight by molecular weight into 1000 divided by what? Capital W. Now you start. Delta TF is equal to what? Delta TF. KF value is given, na? What is the value? KF value? 5.12. What is the weight? Weight of the solute? Weight of the solute already you know, the problem 0.5. Already molecular weight you got now here. Just now we got 64,000. What is the weight of the solvent? How much here? Solvent, benzene, 39. Benzene is a solvent, na? So 39 grams. You just simplify. Finally you are going to get the result. Finally you are going to result. The result is 1.02 you are getting. You try yourself. Finally you are getting like this. 1.02. That is the answer. So he is asking the problem like this. This is the one type of what is the JEE advanced question related to Raoult's law. Right? Note down. Okay, na? I think all of you got this one. Practice in the problems are very important. When you practice the more problems, then you are going to get the what easily get the concepts. Number of problems you try to do. See, one more I am giving. What does that means? Just one more I am giving. Just see here, what does that mean? Just I am writing it, just note down. Liquid, simultaneously you also write with me. Liquid A and B, okay na? Form ideal solution. Form ideal solution. Liquid A and B form ideal solution for all compositions. For all compositions of A and B at 25 degrees centigrade. Okay na? Two such solutions with 0.25 and 0.50 mole fractions of A have the total vapor pressure of vapor pressures of 0.3 and 0.4 bar what respectively. Then asking like this, what is the vapor pressure of pure liquid B? What is the vapor pressure of pure liquid B? This is the question asking. Just note down, all of you. I am repeating one more time. The mole fraction, the liquids A and B. The liquids A and B form ideal solution for all compositions of A and B at 25 degrees centigrade. Two such solutions with 0.25 and 0.50 mole fractions of A, okay, have the total vapor pressure 0.3 and 0.4 bars respectively. What is the vapor pressure of pure liquid B? Like that. Just note down. How to do this one? See here, just now we discussed here, I am erasing this one, okay now? Right? Just now we discussed about the Raoult's law. You see total vapor pressure is equal to, you know now, actually partial pressure PA is equal to P naught A XA, PB is equal to P naught B XB, like that we discussed already. See, I am writing like this, you just see here how to do this means. PT is equal to, take first, with respect to A and B I am discussing here. With respect to A and B I am discussing. If suppose I am taking A, PT is equal to P naught A XA, we write like this. With respect to. Otherwise liquid A, liquid B you take. Better to take liquid A, liquid B, like that I am taking. PT is equal to P naught A XA plus P naught B XB, like this I am taking. With respect to liquid A, with respect to liquid A and with respect to liquid B, I am going to discuss. This is Raoult's law. So with respect to A, what is the total vapor pressure? With respect to A, what is the total vapor pressure? 0.3 na, is it? Yeah. Total vapor pressure A, yeah, 0.3. You take 0.3. So then P naught A, you take P naught A as it is. XA value is given 0. How much here? 25 plus. What is the P naught B? Okay, I don't know. What is the XB? When once you know what is the XA, automatically XB you are going to get now, because XA plus XB is equal to what? 1. You just substitute the XA value in this, XB you are getting now. So what is the XB value here? If you are going to calculate 0.75, you are going to get here, according to this. Don't disturb this one. Similarly, for liquid B also, I am going to consider same procedure. What is the value? 0.4. Here it is what here? You take as it is, no problem. P naught A, and this is how much here? 0.50, is it? Plus this is what? P naught B, as it is. When once you know the what? XA value, XB value, like this only, XA plus XB is equal to 1. So again what? 0.50. Okay now? So this is what is the equation 1. You just take this is equation 1, this is equation 2. Solving. By solving you are going to get the values. By solving, I am writing here, you just afterwards you solve yourself. By solving means you just multiply with anything. By the suitable digit you take multiply, and cancellation is going on. By solving how much means P naught B value are going like this. P naught B is equal to what? 0.20 and P naught A is equal to 0.6. This is bar actually. Okay now? Solving process you know now, you just multiply with respect to 2 here. Automatically it is cancelled here. The PB value you are getting. When once you get the PB value, automatically P naught A you are getting. Okay now? So this is the procedure to consider the problem and solving the problem. So in this way you try to prepare the JEE advanced, because next month you are having now, time is very less. Okay? So today with this I am going to end the topic. If you like this video, please subscribe my channel. Thank you to all of you.